You have watched the lectures, you have seen the formulas, but can you get the points? Welcome to Unit 9 FRQ Masterclass. Today we aren't just doing maths, we are doing exam strategy. I am walking you through real world AP style problems from leaking tanks to variable width pipes. I'll show you how to write those paragraph lengthy justification that graders love and how to avoid the density trap that catches 90% of students. If you find yourself getting stuck during this workshop, that's a sign we should work together one on one. Shoot me an email and let's turn that stuck feeling into a 5. Let's solve some FRQs.
So tell me, you were talking about question number.
Yes, sir. So like sometimes, yeah, I can. Yeah, I think we can do like part B. I have a question for part B. I got it correct, but sometimes they I don't know when to use Bernoulli's principle, like the equation, sir. That's my main confusion.
Okay. So first of all, let us understand what is Bernoulli's equation. So it says pressure plus half of rho v square, that is pressure energy plus rho gh. So sum of all these energies is constant as per Bernoulli's principle. Now just try to understand what is being asked in the question. So if you just look at calculate the speed of the water as it leaves the hole in the side of the tank. So this is something which you can also calculate using Venturi meter. So Venturi meter is something which actually works upon the application of Bernoulli's principle only. So basically, it is a device which actually helps us to measure the velocity of efflux, at how fast a water or a liquid will come out to a hole due to pressure difference. So it is quite basic to understand. Whatever tank we use at our houses, those tanks also works in the same way. So
Okay.
here you can see calculate the speed of the water as it leaves the hole in the side of the tank. So when it is leaving from this particular part, from this particular hole, and it is mentioned that the tank, this particular hole is 5 meters above the ground, and the total height of the container or the tank is 25 meters. So there is a clear difference in the height. So we will apply this equation only. Now let us talk about the different scenarios. So as you
Sir,
can see, the tank is open. Yeah.
I'm confused about one thing though. Like in this equation, right? See, there's
Hmm.
like pressure, and then there's
Hmm.
PG, and then there's rho GH. Isn't rho GH also equal to pressure, sir?
See, pressure here, pressure is pressure energy, and this is
Energy?
potential energy.
Oh,
So pressure energy and potential energy, like these are the things that is being represented here. Whereas if you talk about this pressure, pressure is equals to rho gh. It is calculated at depth.
okay.
Like if there is a certain depth, then we have to calculate pressure here. So from the top, whatever depth it is, so pressure at this point is rho gh or rho gd here in this case as per the diagram. So what
Okay.
you have to infer from this particular relation is whenever the question says that you have to find any of the given unknown like velocity, height, pressure even,
Yes.
you can do that.
Yes.
So if you just look at this particular diagram and we have to find out the speed. So here the tank is open. So the pressure here must be atmospheric
Uh,
pressure.
but what about the pressure at the? Isn't there water pressure at
No, no.
the
At
holes?
the top, as the container is open, so pressure is only atmospheric pressure. Again,
Yes.
again, try to understand. Whenever we apply Bernoulli's equation, we apply Bernoulli's equation at 2 points. Now, as we see in the question, we generally apply this equation at these points. So, suppose this is my first point and this is my second point. So, we will simply say that energy, total energy at point A must be equals to total energy at point B. This is how we apply
Oh,
it.
okay,
So
okay.
pressure energy at point A, again, it
10
is
to
due
the
to
5.
atmospheric pressure is always equals to this one also because this hole is
Oh,
also open. So pressure at this point is also same. Atmospheric pressure is also same. So pressure and pressure will automatically cancel out. Now, if we just write it this way, half rho V1 square plus rho GH1 is equals to half rho V2 square plus rho GH2. So pressure has already cancelled out as the container and the hole is open from, and the pressure experienced is going to be atmospheric pressure only. Again, one more thing. If you just look at the whole and we just look at the top, so the area, let us try to compare the area. So area at the top, it must be way more greater than area at the whole. So when we observe such scenarios, we can simply say that velocity at the top is going to be very much less than that of velocity at whole. So in that case, we just take V1 as 0. So the rest of the equation is being used, or you can say the rest of the equation is being solved. So rho will cancel out here. So half V2 square must be equals to G H1 minus H2, and V2 is equals to twice of G H1 minus H2 root. So this is what the relation we generally use to solve velocity, or you can say this is the equation that we actually have when we are solving venturimeter as well, when we are dealing with venturimeter as well. So that's all. This is what you have to consider. You can substitute the values and you'll have your answer. Got it?
Yes, sir. Okay.
Similarly, if you talk about the third part, that is C, calculate the volume flow rate. So volume flow rate is quite simple. Whenever you have
Volumetric.
to find out, yeah, the volume flow rate means that how much volume of liquid is coming out of that hole, and like what is the rate with respect to time, we can say that.
A1
So
V1 is equal to A2 V2.
no, we just have to write AV. This is what volume flow rate is. Where we have to
Yeah,
find it?
yeah.
From the hole. So we can simply write it area of
I
that hole times the velocity with which it is coming. So velocity we've already found out in the third part, second part. We can
yes.
substitute the value and multiply the same with the
I got that part correct. That
uh,
last part, I think. Yeah, it's part C. The next problem I think was like the next question, but part C.
this one,
Part, part
this one.
Yes, sir. Yes.
So here in this question, first of all, let us read the question, then we'll move to the part C. So there's a large container shown in the cross section and it is filled with a liquid of density 1.1 times 10 to the power 3 kilogram per meter cube. So instead of this, it is also given that relative density of that liquid is 1.1. So again, if it is given as this, then also you have to infer that it is 1.1 times velocity of density of liquid. It might be possible that it is given in that way. It says that a small hole of area 2.5 times 10 to the power minus 6 meters square is open in the side of the container, a distance h below the liquid. So there is a hole that is h distance below the top surface of the liquid. Now it says which allows a stream of liquid to flow through the hole and into a beaker placed to the right of the corner. So there is a beaker which is placed to the right side of it. At the same time, liquid is also added to the container at an approximate rate so that H remains constant. So liquid is also being poured into that container so that H remains same. The amount of liquid collected in the beaker in 2 minutes is this much. So we have given the volume of liquid that is added into this, which is 7.2 times 10 to the power minus 4 meter cube. So you just have to look at the unit also if you don't understand what is given. So basically we are given with volume and it is being collected in 2 minutes. So time is also given. That is 2 minutes. So in the first part it says calculate the volume flow rate of the liquid from the hole in meter cube second. So if you have to find out the volume flow rate, it is again the same area times velocity over time. This will give us, no, we just have to do area times velocity. That's it.
They already no, they already gave us the. You just divide um the volume by the time.
Yeah, for per second, we have to divide it by 2 minutes, that is 60 seconds, 120 seconds.
Yes, sir.
In the second part, it says calculate the speed of the liquid as it exits from the hole. So with what velocity is
Bernoulli's.
going to, get exit. Yes. So we have to apply Bernoulli's principle and we'll use the same relation. So V here is going to be
How do you know which point
twice.
to choose, sir? Which 2 points to choose in
We
Bernoulli's?
have to choose, we have to always choose those points which are open to atmosphere. Keep that in mind. Because if
So
we choose those
okay.
2 points which are open to atmosphere, one energy, that is pressure, is always cancelled out. So equations becomes a little small to solve. So it is going to be 2gh1 minus h2, where h1 is going to be h plus g and h2 is going to be h. So ultimately we'll be left with d only.
What is this? Sir? Is
So
this like some theorem, Torricelli's theorem?
yeah, it is Torricelli's theorem and it is used in Venturi meter.
My
And
teacher
that
said like
Venturi,
it has to be the like we in the AP test like they will mark you down if you do that. They said we have to show that we're using Bernoulli's equation and then we derive it.
yeah.
Like
So whenever we are talking about applications of Bernoulli principle, the first principle, first application we talk is Venturi meter, and Venturi meter use Torricelli's law or Torricelli's equation. So Torricelli's equation is the equation which gives us that how fast a liquid will exit from a given point if it is open to the atmosphere. So this is the result. So how we are supposed to do it? We saw it in the previous question. So that is what we have to do. So
how is it
here,
derived?
the same way we derived in the top. This way only. We took energy at both the points equal as the liquids are flowing. So you can also write pressure plus pressure here, which is being cancelled out at as both the points are open to atmosphere. Density will also cancelled out. So it doesn't depend upon the density of the liquid. It only depends upon the height of the container or the point. And this is what your result. That this is what equation we are supposed to have. That's all. This is the only thing that you're going to use, not more than that. There are certain situations, there are certain conditions where the equation get a little tough, but you don't expect that that will be asked. Very rare possibility that they are going to ask that. Most of the times they will ask you the application of this only, that how you can use Bernoulli's equation in different scenarios. Always remember you have to choose 2 points. Once you choose those 2 points, you just have to put Bernoulli's equation, that is energy at those 2 points equal. Substitute the values, you will have the unknown, whichever you are required to find. This question get a little bit tough if the container is closed. If this container is closed, the pressure at this point is not equal to pressure at this point. Then you have to solve the pressure. Then you have to find the value of pressure. So that will make a little bit of difference. So
If pressure is
keep
not
that in mind.
what is not the pressure?
If the container is not open, as in the question says,
Oh,
container is
okay.
open at the top. If it is not open, then you cannot take P equals to this P.
So I have a
Pressure is
question,
going to be
sir.
different. Yeah,
What if we had like the container, right? But then
yeah.
it was closed, but there was a small buffer. Like it was not completely filled. Like it was a closed container that's not completely filled. So what would the pressure of the air be inside then?
You won't consider that pressure. If there is a small space where there is some part of air can live, so you won't consider that. You just have to deal with pressure at this point. And also at the top of the container, there is the pressure is zero. Because how you can calculate pressure? You can calculate pressure using this relation only. And at the top, if the container is closed, pressure is going to be zero. That's all. But here it is going to be P naught, that is 10 to the power 5 pascals, which is 118.
Okay.
So in the second part, it says calculate the speed of the liquid as it exits from the hole. So you can simply put the values and find out. Try it out, solve it, see whether you're getting the correct answer or not.
Uh, think I got the correct answer for this, sir.
Okay, if
Meters
you
per
got it, it's fine.
second. I already did these questions.
That's good.
Yeah. It was just the
So
Bernoulli confusion. Yeah. So then for part B, I got 2.4 meters per second. For C, I got 0.2939 meters.
nice. Then
Then for part D, what was the question? Oh yeah, if the height reduces to half of what it was, then you have less potential energy, which means less kinetic energy, and less kinetic energy means lower velocity. So then, because of kinematics, if a lower velocity will result in a lower displacement, which means that the water jet will be closer. to the beaker than
Correct.
what it was before.
You have whatever you have assumed is completely correct.
Okay.
That is how you're supposed to relate it.
I think the fluids topic is a bit easier compared to rotational or like simple harmonic motion, to be honest with you.
Yeah, comparison. See, it's all about understanding. If you understood a concept, it automatically becomes easy. And for fluids, we go through with each and every topic, so that's why you also feel that it is a little easy. Whereas in the other topics, we didn't go through that way. So
Yes, sir.
that makes a different. That's all. Okay, one more thing. How many you tried each and every question on this file?
I've tried this question already and the
Okay.
next one as well. Yeah, the next one I had no problem doing. It was the problem I had was with 2008 B4. So it was two questions after this. The one with 50 degrees. Next one. Yes, this one. I didn't know how to do part C. I could do A and B, but not C.
It is a simple projectile question. Let us see. Let us see. So question says a drinking fountain project waters at an initial direction of 50 degree above the horizontal. The water reaches a maximum height of 0.15 meters above a point of exit. Assume air resistance is negligible. Calculate the speed at which the water leaves the fountain. So if you have to find out that how with what speed it is exiting, so again see. So what it is the maximum height, and maximum height is attained by the vertical component of the velocity, which is always v sine theta. At this particular point, v sine theta will become zero. Velocity at this point becomes zero. So what
Yeah.
we can use? We can use third equation of motion. So according to third equation of motion, final velocity square minus initial velocity square, which we have to find, which is v sine theta. It
750.
is going to be v square sine square theta. It is equals to twice of g into height, which is 0.15.
Oh, so we take the vertical component of it.
Yeah, because we're dealing with maximum height.
Yes.
So here v square sine 50 degrees whole square is equals to twice of 9.8 times 0.15. So v square is going to be, you just have to solve the values and you'll have the velocity. That's all.
Yes, sir.
In the second part, it says the radius of the fountain exit hole is 4 times 10 to the power minus 3 meters. So we have given the radius. Calculate the volume flow rate of the water. So once you have the velocity, you have area, you can simply multiply velocity and area and you can have volume flow rate. So that is also pretty easy. So Q is A times B, which is easily calculable. C part. The fountain is fed by a pipe that at one point has a radius 7 times 10 to the power minus 3 meters and is 3 meters below the fountain opening. So you can assume that there is a pipe which is like that, which is 3 meters below the opening. The
Oh,
density
yes,
of
this was
water
the
is
question. Yes.
calculate the gauge pressure in the feeder pipe at this point. So we have to find the gauge pressure at this point. So
Sir,
here,
I have a question.
yeah,
So, like, my question, right? So here, the answer key said using Bernoulli's principle. But then I was wondering why can't we just take rho GH?
answer says that we have to use Bernoulli's principle as per the key. And you're asking that why we can't take rho GH.
Yeah, why can't we just plug everything in rho GH?
See, if we have to find out pressure at this particular point,
Yes, sir.
which is 3 meters below it, like let me mark it as A, let me mark it as B. So if I have to find pressure at B point, also I am assuming that A point is open to atmosphere, so pressure at A point is P naught. So if I have to find pressure at point B, so it is going to be P naught plus rho GH.
Yes, sir.
When can you use this equation? When water is static.
Oh. Oh, because it's like
Because,
potential energy. Potential energy is not moving, it's like stored.
yeah. So when water is
Oh.
static, then you can use this relation. Again, you have to incorporate P naught as well if it is static. But
Oh. Okay. It's moving in
there,
this case.
yeah, it is moving, it is coming out with some velocity. So there must be some energy component that we have to deal with. And that energy will not allow us to use this relation directly here. So we have to use Bernoulli's principle. So as the question says that the radius is this and it is itna meter below the fountain opening, and the density is also given, find the cause pressure. So we have to simply find out pressure. At this point, we can take the pressure is zero because it is at depth. No, we have to find pressure at that point only. So we can take pressure at this point as P. At this point, the pressure is going to be P naught. There is a velocity, so we can take the kinetic energy component as well. And it is above the surface, above this point. So we can take energy at this point as rho gh as well. So now let me
Prove
assume
to
that
you.
this is
Okay.
my A point. So total energy at A point must be equals to total energy at point B.
Oh, so we define the initial, the velocity inside, and by using the volumetric flow rate first, right?
Yes. So at A point, it is going to have this much energy.
The point A is like out the fountain hole, the exit hole, right?
Yeah, it is the
Okay.
exit where the liquid is coming out, and B is the point where we have to find out pressure. Rho
Okay.
GH. So it is going to be P that we have to find plus, and we assume that here the velocity is zero. Rho GH. Now, this is going to be zero at this point. That is A point. It's all about where you're taking reference and where you're not. So you have to see, you have to practice a lot to get this thing. Always remember, if water is in motion, whether we are dealing with the dynamics of fluid, then we have to always use Bernoulli's principle. If fluid is at rest, we are dealing with static fluid, then we can go with that equation. That's all.
Okay.
Although, if I talk about gauge pressure, so gauge pressure is calculated by this particular relation. Gauge pressure is something which is always calculated by keeping this thing in mind that which particular, you can say, point we are at which point we have to find out pressure, and at the other point we have to know the pressure also. If we don't know the pressure at other points, then it is going to be difficult to find out gauge pressure as well.
Yes, sir. So how do we calculate the P naught and P?
P naught is always known. Atmospheric pressure is 10 to the power 5 Pascal, whereas P is something we have to find. So we'll substitute the values into that relation, and we have the value of P that we are asked to find out.
Okay, wait, let me write this down, sir. I did not write this down in my response.
Sure, sure. So
Okay.
basically it is not solved here. That's why you was little confused.
Yeah, I did not it makes sense now because I was always thinking we could just use GH, but then so it's a static only. So it's P naught plus rho GH plus sorry, P naught s- half uh rho V squared is equal to P plus rho GH. So 10 to the 5 plus half times 1,000. Uh, and the velocity is what? 2.2383, 2.2383 squared minus rho gh. So rho gh. Oh, so I would plug in the depth here, right, sir?
Yes, 3 meters.
So that would be 1,000 times g times 3. So then that would give me what? Let me plug that in my calculator. Okay. 2.2383 squared minus. I got. Wait, this seems wrong. Wait. I got 73,105 pascals.
73,105.
105 pascals, yeah. Because we were solving for P, right? For P.
Oh, I don't think so. It should be wrong. What's the answer
It's
key
right.
says?
Let me check, sir. So the answer key for 2008 B4 says that it's 31,600 pascals. Oh wait, sorry. Is
31.
this the wrong? No, no, no. This is the correct problem. Yeah. Wait. 1 second. Yeah, this is the feeder one. Yeah, the fed by a pipe. Okay. Yeah, they said it's 31,600 and 600 pascals. Wait, I can send you this PDF. 1 second. I just found this from online, but it seems right. I'll send it in the group chat, sir.
Okay. Okay,
Okay.
one thing we haven't considered. That's what is wrong.
Oh,
So,
okay.
in order to push water to exit from point A, the water must be pushed from point B as well. So, there must
I
be
must be
some
moving.
energy at, yeah, it must be moving at point B as well. So,
Okay,
we
okay.
have to consider kinetic energy at point B as well. So,
Okay,
we can
sir.
mark it as V1, we can mark it as V2. So, as you can see, V1 we found already in the first part, which is what? 2.23.
2.23. Oh, so we need to add the kinetic energy here as well.
Subtract.
Yeah.
And A1 is the radius of fountain exit is this one. So, if you have to find A1, it is going to be pi r1 square. So, we have to put this value here. Similarly, V2, we don't know what is V2. So, we have to first of all find out V2 because with what velocity water is going above point B. Similarly, for A2, they have given the radius. So R2
So it
square
is
times
like
pi is going to be A2.
volumetric flow rate.
Yeah, so A1 V1 must be equals to A2 V2. So from here we can find out V2, which is going to be A1 V1 over A2. So pi will cancel out pi, R1 square, R2 square times V1, which is 2.23. So R1 by R2. So what is R1? It is 3. It is 4. R2 is 7. So 10 to the power minus 3 will cancel out. So 16 over 49 times this. 16 over 49 times 2.23. So if you solve it, you'll have the value of V2. What will come
Yeah,
out?
I'm doing that. 1 second. 4 times 10 to the times 2 divided by 7 times 10 to the negative 3 times 10 to the negative 3. So the velocity at that point, the point below ground, would be 1.279 meters per second. So then we
So
plug
when
that in.
Yeah.
We
So let
plug
me
that
write
in
the
here.
final equation. So P is equals to P naught plus half of rho P1 square minus V2 square plus rho G H. Now we can substitute the values in this equation. Try substituting it.
Yes, sir, I'm doing that. 1.2. Again, I got the same thing.
Not possible.
I got 72,287 pascals. That doesn't seem right. Did I plug something in incorrectly? No, nothing incorrectly.
What is density?
1,000.
How's V1 is 2.23.
Yes, sir.
We have to square it.
I squared it as well. Minus rho
Are you sure
gh.
this is 1.279?
Let me double check, sir.
Because it is not even, it is not 0.5. It is less
Wait,
than
sir.
that.
So for the equation, we said a1 v1 is equal to a2 v2, right? So I said 7 times 10 to the negative 3
10 to
times
the negative 3
v1
will cancelled out on both.
with the fountain is by 1 point. Yeah. So I said times 10 to the negative 3 times v is equal to 4 times 10 to the negative 3 times 2.2383 meters per second. And then I just solved for v1. Maybe I didn't wait. Maybe I did the calculation wrong.
So this is the fountain outlet, I can assume. And this is the point which is 3 meters beneath it. Distance between these 2 points is 3 meters. The water coming out from this point is at a speed of 2.23 meters per second. Now just think about it. At point B, what amount of energy the water should have at point B? First of all, total energy at point A must be equals to total energy at point B, right? Then only it is able to come out with that much velocity. So at point A, it must have kinetic energy that is half rho V naught square, right? Similarly, at this point, from point B, it is above 3 meters. So we must have to push water 3 meters above that point B. So when it reaches this point, it must have some potential energy as well, which is rho gh. I'm taking this point as ground. So if I'm taking this point B as a ground, so half rho V naught square plus rho gh must be equals to whatever pressure at point P we have to create to push it upward, plus the velocity with which it is going to move upward. That is half rho V B I can write. I can write it as PB square plus as it is on ground, so we can write rho G times 0 because ground is my reference frame from where I'm actually measuring the height. It is going to be rho G 0. Now we have to find P pressure at point B. So it is going to be rho GH plus half of rho V naught square minus VP square. If it goes this side becomes negative. If I take out common, VB becomes negative. So this is the equation that you have to use. Now try plugging the values into this equation. VB, are you there?
Yes, sir.
So VB is what we found, 0.72 or 73. V naught is 2.23. Density is 10 to the power 3. H is 3 and G is 9.8. Now plug in the values and tell me what is pressure at point B. First of all, try to understand the concept. Like what type of energy is required at what point and why is it required at that point. That is also important to understand.
Okay, let me plug this in, sir. Okay, let's see. So PB. So rho GH in this case would be 1,000 times 9.8. I think I set my equation up incorrectly previously. That's what I think
Yeah,
happened.
that's what I was trying to make you understand.
V naught squared is 2.23 minus 0.73 whole squared. 30,525 pascals, sir.
This is how you have to solve it.
So I don't know what happened in my equation though, I think, sir. I think what happened was I was including 10 to the 5.
No, no. What you are doing is you are taking potential energy at this point as rho gh and potential energy at this point as zero.
Oh, it's
That's
the
what
other
makes
way
the
around.
difference.
It was the other way
Yeah, it's
around.
the other way around, right?
Oh, okay. Okay, I have to pay attention to where what point is to has what energy.
Exactly. You always need to figure out that which point, like what is the energy at whichever point is given
Okay.
to make sure that you get as much marks as possible in your exam and to cover as all the units altogether. So it's better to go with unit-wise test as well as complete
The full
syllabus mock
test.
test.
Okay.
So it is 31st today and you'll be back by 5th. So as per this particular schedule which we have planned, like the class is weekly. So 5th of April, it is Sunday. Then according to our plan, it is going to be 8th of April on Wednesday. I just wanted to give you the date so that you can prepare each and every unit and also you can give test accordingly. So before these, if you have these dates in mind, you'll be able to prepare better. That's what I believe. So before every class, or you can say after every class, after every revision class, you'll be having a one small test. That test might include 10 to 15 MCQs, 2 to 3 FRQs,
Okay,
and
sir.
that too completely based upon the requirement. 16th, then after 16th, we have 22nd of April. We'll try to make sure that we don't miss any class. If we miss, so we just try to cover it up. 22nd, then 26th April, again Sunday. After 26th, we'll be having 29th of April.
Yes, sir.
We'll be having exam on 6th. So again, we have 3rd of May. Now, what I believe we should do is we should go one by one to discuss each and every unit. Like for example, for 5th of April, as it is on Sunday and we'll be doing fluids. So let us keep these units aside as of now because you are very much prepared, I believe.
Okay, fluids, yes.
So from 8th of April, let's start from unit 1.
Kinematics.
Unit
Okay.
Unit 1, that is kinematics, will do the revision here. If you have any sort of doubts in that unit, you can ask those doubts. On 10th of April, you can do the test.
Okay. So I'll just tell you, like, I can tell you my doubts for like some of these. The
Yeah,
kinematics, it's just regarding the components, like at a certain angle, Though,
yeah.
like in general, for
So in
kinematics forces, like those are my problems I have with those are like components of them. If it was at an angle.
Yeah, I understand. So what we can do is whenever we are doing that revision, you can just let me know that these are the questions or these are the topics that I face difficulty, and we can discuss that. So this way you'll be able to revise each and every unit, and as well as you'll be able to evaluate yourself that how much you are prepared. So accordingly, you can decide whether we need to do extra class or something like that or not. Otherwise, we can just follow or you can just stick to this. Then we can again on Wednesday, unit third. Then again, you'll be having test on 17th. Again, make sure that you don't miss the test. It doesn't matter whether you're doing class or not, but test is important because test will help you to evaluate yourself.
Okay, sir.
Okay. On Sunday, 19th April, we'll revise unit 4. I'll also try to make you revise each and every unit on that given day only. You can do it on 21st,
Yes, sir.
21st of April, again, the same unit test. Then we'll practice or revise unit 5 on this particular class. On the next particular time, 25th, I believe, we can give test of this particular unit.
Yes, sir.
Again, so the test which I'll be doing is, again, you have to do honestly. You have to just simply take the paper, solve it by considering all the things. Once you're done with
Can
the
you give
paper,
me a time
make,
limit, sir? Like a time limit for each one, so I also know how to pace myself.
yeah, exactly. You'll be when you get the paper, you'll get all the information. Don't worry about it. At how much
Okay.
time you should take for completing that paper. Yeah, at what time you have to do it completely depends upon you. Whenever you feel like that you can now attempt the paper, you should do that.
Yes, sir.
Then unit 7 on I believe the 1st of May, you can do the test of unit 7. Then on Sunday, 3rd of May, it is general class. We'll try to cover how whatever difficulty you faced in any of the given thing. So I'll be doing a mock session discussing some random questions which are being asked in the previous sessions, previous exams, or the pre-IQs basically. So the random question discussion. After that, as 6th will be your exam, I would say. Okay, just tell me one more thing before that exam on 6th. Do you have any other exam in the beginning of that month, May?
I have microeconomics, and I don't know when
When?
my Calc BC exam is. Once I can check, sir. It tells me on my college board website. I'm actually just very worried for my Calc BC one because I don't think we're going to complete all the topics, so I have to start studying the new topics myself because the teacher did not schedule the class well. So now I have to suffer because of him.
But this is something which affects
Like,
every student.
yeah, I know every student will be affected because he missed. He's not going to be able to cover one major topic, one or two major topics in the whole Calc BC curriculum, which is the polar and parametric stuff. Um, yeah. So my exam day for Calc BC is 11th. Oh, microeconomics is 4th, May 4th, and physics is on the
Okay,
6th.
so we can't do anything between that. It is on 4th, so
No, no,
5th
sir,
you
it's
have a
fine,
day.
sir. I can do microeconomics in my sleep. It's fine. That one is easy.
Okay, so what
I'll
I
worry
what I
about
was thinking.
physics.
Okay, so what I was thinking is that on 4th and 5th, on 4th of May and 5th of May, we'll do a proper MOOC exam. Like I'll share
Okay,
a
sir.
proper MOOC exam and we'll do the discussion so that you'll be able to understand that how much we can do in the exam. So on 4th of May as well as on the 5th of May, we can do a proper MOOC exam of AP physics pattern. Same
Okay,
timeline, same
sir.
pattern, same number of questions,
Okay.
same level of questions even, and we'll discuss the same on the same day. Like
Maybe you
you
can
did,
like communicate this to my mom as well, so then she'll know the schedule.
I'll share this thing so you
Okay,
can
okay, sir.
make her understand. Always remember the units. We'll start it from the unit one.
Okay, sir.
I believe you are confident with the unit fluid, so you can do that. Although we didn't go through with each and every unit yet, and I don't know how much you know about these units. So
Yes, sir. Of
as
course.
we have started classes, so it's my duty to make sure that you know each and every unit well. Also, just stick to that. Just set a time at what time you want to appear for the test. It's completely up to you, up to according to your schedule, according to your comfort. But just do it honestly so that you can
Yes,
evaluate.
of course, sir.
It's not about you have to score here. What's important is you have to score on 6th of May. That is the main objective. And in order to score at that point, complete these tests, appear in the mock session, appear and do the mock test with 100% efficiency, you can say. And again, at 6th, I guess you'll be able to do it. What is the general time for having those exams? Like, what is the timings?
So the
Is it in the
timing
morning at
12
what
p.m.
time?
or 12 p.m. and then Calc PC is 8 a.m. or both are 12 p.m. though.
Okay.